Hey everyone, thanks for coming. Gonna give it a couple more minutes for everyone to join in. So we'll start in like two minutes or so, and we'll get to introductions then. But
Like a lot of people are filing in right now.
yes, it does seem that way. Good. It's gonna be a good one.
Yeah. Thanks for the call, Jet. Good technical topic.
Yes.
Customers that I've talked to that have this product are very pleased with it, Mike, too. Just so you know, they swear by it.
Thanks. Yeah. Well, don't forget they make lovely gifts, weddings, anniversaries.
Yeah.
Yeah, we're pretty proud of it.
Good.
We came a long way. It wasn't always this fabulous.
So HQ is near Cleveland.
Cincinnati.
We're in Cincinnati.
Oh, down by Cincinnati. Okay.
Yeah. We're right by Kings Island, if you know where that is.
Mm-hmm. Great.
Yeah.
Mike, where are you located at?
I live in Loveland, Ohio, right by Kings Island. I can see the fireworks every night from my apartment.
I see.
Mm-hmm. I'm a Columbus, Ohio native, but I moved here years ago.
Oh, I'm sorry.
Yeah, the therapy's going well.
Go Blue.
Michigan fan, I'm
right.
sure.
Yeah.
Right. Yeah. Everybody in my family went to Ohio State except me. I went to the Ohio State's community college.
Oh, there you go.
Yeah.
All right. Well, I think we'll get started here. We got a good amount of people that have joined. I'm sure a couple more will trickle in as we get started. But thank you everyone for joining today. My name is John McNamara. I'm a technical sales engineer here at Sodic Plus Tech, and we're happy to have Mike Henderson from ColdJet joining us to give a presentation. Wanted to also thank some of our folks here, Kohei Shinohara, Bennett Howard, and Len Hampton. And I'll
Bryce.
and Bryce is in here.
Yeah.
Bryce is in here. Yeah, he just not.
Yep,
I didn't
right
share
here.
the screen. Okay,
There you
and
go.
Bryce. Sounds good. Yeah. So I'll let them introduce Kohei if you want to start.
Yes, thank you for being partner with Sodic to share your technical knowledge, CallJet. This is a very good opportunity to work with the professional expert in our industry. So appreciate the speaker and appreciate the attendees. Thank you.
Bennett.
Yeah, thanks for joining, everybody. I'm gonna hop off here in a second, but I'm interested to hear what Mike has to say, and always looking to learn more about reducing downtime. So thanks, Mike.
Sure.
Bryce.
Yeah, looking forward to this. We've done a few shows with ColdJet in our booth as well too, and it's always a good demo to be a part of. So definitely interested to see what you're going to be talking about today.
And then last but not least, Len, our national sales manager.
Yeah, thanks, John. I'm national sales manager. Been here 19 years. These Sodic and Friends platforms, we did I don't know, almost 40 of them throughout COVID, and we're bringing them back now. We've got a couple others already in the queue. Some are material manufacturers. Maybe John can allude to that later in the maybe at the end of the presentation. But ColdJet's always been a real good partner of ours, like Bryce mentioned, at different trade shows. We do live demos, things of that nature. But keep in mind, keep your emails open. We're going to keep you up to date with, now we're bringing Sodic and Friends platform on the road regionally at some of our other regional offices in Connecticut, in the Southeast, Michigan, Los Angeles area. And we'll keep bringing fresh new technology folks that we partner with all the time at these local events that we're going to be doing. So keep your eyes out for that. We just finished one with Bennett at Yorba Linda, California office. It was well attended, and Beaumont did a rheology full day event, free of charge, of course. And keep an eye out for that as well. But we'll let Mike kick this off, and maybe you could explain about the platform a little bit, John.
Yes. So thanks, Len. I will. Yeah, exactly. I'll get into how this will all work. So we have Mike Henderson here from ColdJet to give his presentation on their equipment, and it's very interesting. We were doing some dry runs earlier, and a lot of interesting material. I'll start with a little bit about Mike. He's been a regional sales manager.
Maybe some rules about the chat function and questions and answers, things like that.
Yeah, so he'll give his presentation, and then it'll be about 40 minutes or so, and then we'll have Q&A at the end for about 20 minutes or so. And there's a Q&A tab at the top of the screen that you can use to submit those questions throughout the presentation. And at that time, at the end of it, I will read those questions to Mike, and he will answer them.
Great.
So yeah, a little bit about Mike. He's been a regional sales manager for ColdJet since 1994. He brings 3 decades of invaluable experience in dry ice technology and specializing in dry ice blasting applications such as adhesive and asphalt removal, automotive and historical restorations, coatings and corrosion removal, equipment and mold cleaning, and surface preparation, among many others. Also, as Len mentioned, we have 2 other Sodic and Friends coming up, and I wanted to just mention those real quick here at the beginning. We have SigmaSoft virtual molding coming up August 6th, where they'll talk about optimizing part cost and design using simulation. And then we'll have Scienco, a material manufacturer, on September 10th, they're discussing their specialty polymer usage in healthcare applications. So without further ado, I'll pass it off to Mike to get his presentation started.
Great. Thanks, guys. I appreciate the introduction, and we're really happy to be a part of this. I'm going to go ahead and just get started. A little bit about me. Like John said, I've been here 31 years as a regional sales manager. I covered, 20 some states and the Caribbean islands. I've done over 10,000 demonstrations, consultations, installations. I am proud to be the most tenured applications guy on the planet. So as it relates to this, so no charge for that. There's a picture of me in March of 1994. That was my first week here. I didn't know what I was getting into. Back then, this thing was invented to strip paint from aircraft by Lockheed Martin. And when they found out that this doesn't strip paint, nor is it good for the aircraft skin, we were a technology looking for applications, and we got contacted by the tire industry. A tire mold, when the release agent loses its properties, takes 12 hours to disassemble, clean, and put it back together and start making tires again. I can clean one, and while it's hot on the line, in 11 minutes. So we had their attention. But then we discovered everything's molded. Barbie doll heads, dog bowls, shoe soles, right? In this picture right here, I'm cleaning a dashboard mold. The off-gassing and coloring is fouling the mold. And of course, to take that whole thing apart and clean it is a long day and lost production. And you've got an expensive part that scrap is expensive and stuff like that. Okay. So that's enough about me. This is our global headquarters in Loveland, Ohio. If you don't know where that is, we're a suburb of Cincinnati. This is where we house our upper management. All of our engineering R&D is done here, and our world-class manufacturing facility. So we do all our own laser cutting, machining, press braking, welding, wire all of our own panels, and assembly. We also house parts, and we have a whole team of service members taking calls for parts, service, stuff like that. And then we have 30 some people in the field. We have 70 people in our service industry. Okay, so we also have bricks and mortar in Belgium, Denmark, Poland, Spain, Japan, 4 places in China, uh, uh, Cambridge, Ontario, Monterey, Mexico. We're truly a global company with sales and service and, marketing and whatever else you need. In the past 40 years, we have installed about 25,000 of these things. That map there, although animated, is pretty accurate. Below there is an accurate list of our fan base, if you will. Okay, dry ice is just simply CO2. CO2 is out here. We're exhaling it. It's being released by the ocean and volcanoes and other manufacturing processes. Dry ice is of course cold. It's 109 below Fahrenheit. What did I do wrong here? Okay, sorry. It's 109 below. Dry ice sublimates, and that means it goes from a solid to a gas, often confused with evaporating. Sublimation going from a solid to gas, leaving absolutely zero secondary waste stream, water, residue, anything. Dry ice is safe for literally hundreds of applications, including food, pharma, medical devices, nuclear, semiconductors, all these difficult applications. All the dry ice in the world is made from recycled CO2. So we're using a byproduct. And here's how that works. When you distill grains to make ethanol or alcohol or ammonia, those are all, spirits. So they're made in a great big moonshine still. Of course, if you know anything about distilling or brewing, there's a byproduct of CO2. Also, the latest trend is to capture farm waste and composting, and that also puts out CO2. So we capture that. That's usually done by a industrial gas dealer, Praxair, Airgas, one of these guys. They then scrub it and pressurize it. When you pressurize CO2, it liquefies and becomes LCO2. That way it can be stored and trucked and delivered until it needs to be used. The California Air Resources Board, which is the strictest governing authority on greenhouse gases and such things, states, and I'm going to read this to you. Due to the fact that dry ice is recycled CO2, it will not contribute to your greenhouse gas score. The carbon footprint is paid for by the ethanol plant or the farm. It is not counted a second time. Okay, so you don't need to worry about that. Okay, so the way it's made. So here's a hypothetical dry ice production guy. He's received a silo full of LCO2. It's piped over to our machine. We make dry ice production equipment, and we make the cleaning equipment as well. So this thing, through hydraulics and electricity and stuff, extrudes the liquid CO2 into dry ice, and then it's stored in a bin there that keeps it for a week. Okay, so when you take a delivery of this bin, you scoop out of it as you need it, and next week they bring you a fresh bin and they pick up the empty. Dry ice is made in different sizes for different reasons. On the far left there, that is a 3 millimeter pellet. That's usually what's used for cleaning, which is what we do. And then you can make various sizes, but that guy's holding a 16 millimeter pellet. These are very popular in the shipping of food and medicine and biochemistry. And then also blocks are popular around the world for different applications. For instance, the airline industry, that trolley that goes up and down the aisle has a place for a block. They call that an airline cup. But anyway, you can get dry ice in all kinds of forms. Dry ice on a national average is somewhere between 30 and 80 cents a pound, depending on how far away you are from the source. So it's the transportation cost that causes it to vary. For today, when I mention it, I'm going to base it on an average of about 40 cents a pound. Okay, where do you go get it? Well, you can call any one of the big dry industrial gas supply houses, Praxair, Aerogas, all these guys, Linda. And then there are many welder's supplies. If you're a rural spot, you can get it from a welder's supply. Most of them have caught on to what we're doing. They have a lot of CO2, so they're making dry ice. And then there are they're making dry ice and delivering it out to the world. You can get dry ice just about anywhere in the world. There's a lot more dry ice being used than you can imagine. Okay, so here's a scoop of dry ice. He's scooping it into the machine. The machine then meters the pellets into an airstream and sends them out through a gun and nozzle. Okay, this particular machine is popular in the mold business because it will take the 3 millimeter pellet and cut it down to a 0.3 millimeter pellet and anywhere in between. So if you're trying to achieve a certain gloss level or something like that, you might need to dial in a recipe of pressure, feed rate, and particle size. Okay, so operator can dial in so we know who's running it. He can specify the project and exactly how much ice, air, and consumption and recipe he's using. So we don't want him to be able to overdo it or underdo it. And then it has IoT in it, so it'll send the supervisor a report on, how much ice he used. Because if he used 40 pounds one day and 400 pounds the other day, we need to know that. But also those reports can go into a file. So that if it's a critical part, a medical part or an aerospace part, and it needs to be looked at later, it can be done so. This machine also can tell if it's feeling sick or if it's pulling a funny amperage. So it will send the supervisor a note, hey, this thing's doing this. We can get online, look at it, diagnose it with you, and do something about it before it becomes catastrophic. We'll talk more about that later. That's how the machine looks. It's in footprint about the size of a carpet cleaning machine. Okay, that's how the dry ice looks when it's coming out. Often people think, oh my gosh, this dry ice is going to be flying all over the place. When that pellet strikes the surface, it immediately sublimates back to a gas. So all you ever see is a vapor path coming out. You're not covered with dry ice and throwing dry ice all over the place. Okay. Here's how it works. So we're sending these pellets out. They're coming out somewhere between 900 feet and 1,000 feet per second. They strike the surface, and what happens is the contaminant becomes cold faster than the substrate. In your case, it's off-gassing and stuck on plastic and stuff like that. So it releases its bond. So, and then there's also something called gas expansion. And that's when you force the sublimation of that pellet, there's a little mini explosion that happens. And that gives you a lifting effect. Okay. So I'll recap. There are three things. There's the impact of the pellet, and it's not abrasive. It's not enough to wear the metal in any way, shape, or form. And we'll talk more about that. There's the impact, there's the thermal shock, so the contaminant becomes cold faster than the substrate, and the gas expansion. Those are the three properties that make this possible. Okay, we have literally 100 applications in 52 industries. Dry ice is non-toxic, non-corrosive, non-abrasive, but non-conductive. So often you may buy this to clean your tooling, but motors and robots and forklifts and things can all be cleaned with any water, chemicals, or disassembly. But we're going to focus on plastics today. So the most popular and the fastest payback on one of these things is when you have a tool where you are at capacity, where you're making as many parts as you possibly can. And the cost to shut the press down, the mold machine down, and take it out of the press and go bench clean it and bring it back is, a loss of production, scrap, the whole deal. Here is one of our own, Giles Garrison, at a show cleaning a Sodic mold machine while it's online. Look, you can see he's one-handing this thing. It's easy to run. It's nice and cool. It's the most popular job on site. Trust me. Secondly, there's bench cleaning. Okay. The mold comes out because you're going to swap out the part, but they want to clean it before it goes back on the shelf. Well, cleaning a dirty mold is a lot of work and a lot of chemicals, and it's unpleasant. But so if you can clean this thing in minutes instead of hours to get it back on the shelf and looking sharp and ready for its next run, the guy that has to do this is going to send you a Christmas card. We also discovered that we can do a certain amount of deflashing, deburring. Okay, so I first discovered this. It was a medical device plant. They were molding a spinal implant out of PEEK. And then it went into the machine and it got machined, and then ended up with a million little burrs and hairs and stuff on it. So, they got a guy with a microscope and an X-Acto knife, and he's shaving these burrs off of this thing. And this guy can maybe do 5 an hour. Okay. So what we did is we fixed a nozzle. We put a whole bunch of these things on a jig, and he just runs the parts underneath the stream of dry ice. Now the guy's doing 12 a minute. And it's not, just taxing on him and his eyes. And also that X-Acto knife, you can mess up the part. This thing doesn't mess up the part. So it eliminates all that. And, it's an expensive part. Okay. So oftentimes when this is discussed before it's understood, we use the word blasting because it gives you the mental picture of, a hopper machine, compressed air, gun and nozzle, and media. But blasting by definition is associated with abrasion. We only say that because so put a picture in your mind. This does not abrade anything, okay? To prove it, we went to Kettering University. They have a plastics college, and let them do the test. They in their test, they blasted the left side of a part and a right side of a tool, and examined it and found absolutely zero tool wear. There's something out there called the Mohs hardness scale. And this is where they've taken various aggregates and measured their hardness with a scratch test to understand it. It's a blasting thing. Dry ice, talc is rated as a number 1. Diamond is a number 10. All right. Now, dry ice is a 1.5. All right. Your fingernail is a 2.5. All right. So this is softer than your fingernail. So just to fortify that we are cleaning with the science, not all abrasion and tool wear. Our little joke around here is that we can take the M off an M&M. Now, there's no real application, but we're going to do it right here just to show you. I took the M off that M&M without cracking the candy shell. And because it's non-toxic, I can eat the M&M. And this may be why I'm chubby, but because, it's very gentle. There's no other way to show it, I think. The other big question, the concern is, oh my gosh, we're going to shoot this cold media at this hot tool. The tire industry had the same problem when we approached them, because that tool is at 380 degrees. It's a great big heavy aluminum mold. So we got a guy to do some testing, and what they did is they set thermocouples at different levels down in the tool, and they cleaned the tire mold. Well, we figured out we're only changing the surface temperature by about 20 degrees. There is no leaching in of the temperature. But really, 109 below is not so cold that if the tool were actual room temperature and you threw it down in the dry ice, it's probably not going to cause any problems. But the test shows the cleaning does not leach in any temperature. A company that we're going to remain anonymous with didn't believe us. They went and did their own testing, but they were happy to share the results with us that micrographic examination showed that there was no stress or change in any way to the metallurgy of the tools. And then that plant bought 17 cold jets, and they have one in each plant. And that was years ago, and they still have them and use them today. These are the kinds of things we're trying to get rid of in the world. Okay. All that stuff you see there, Scotch-Brite pads, spray cans of solvent, spray bottles, rags, gloves, all go to the landfill. When you use dry ice, none of it goes to the landfill. So here's the way you would do it in the old way. This guy is going in here with a solvent, which is unpleasant. I mean, look at the work that's like flossing a cat. Okay. Look at my guy on the right here. It's nice and cool. It's the most popular job in the plant. Anybody can do. Look how clean that is. And he's getting every little nook and cranny without killing himself and re-examining and redoing it. It's just a faster, better, simpler, more comfortable method. Overall equipment effectiveness. You guys know what this is. This is a score that's given to a production equipment. Is it running as best it can, as fast as it can? Is it putting out the parts that you expect it to? Its design point. And are you getting quality points, or are you getting scrap? Okay. If you're getting 100%, these are all running just right, which almost never happens. By applying dry ice cleaning to your PM process, all of these scores go up dramatically. Your also, when you apply this, your average time between failures goes way up, and your average time to repair goes way down. Here's a scorecard of a particular piece of production equipment during manual cleaning. Okay. Here's what the same scorecard is with dry ice cleaning. Somehow that all turns into math and money, but that is real stuff. People often ask us, well, you have a number of pieces of equipment. What should we buy? Okay, well, the little tabletop machine next to the Sodic there is very popular with injection molders. In our world, we have high flow and low flow equipment. That is what's known as a low flow machine. It plugs into any quick connect and plugs into the wall. Okay, now if you look to the right there, that little ice rocket machine is a high flow machine. You would have to plumb that up to a high, like a 1/2 inch or a 3/4 inch airline. Next to it is a more substantially built machine, heavier duty. This is what people drag out into oil fields and stuff like that. But some people just want a heavy duty machine. Now, are these perfect for cleaning your molds? Not really, but they're great for the housekeeping, the ancillary benefits, cleaning motors, cleaning robots, things that control panels. Just doing regular housekeeping will bring your electric bill down and make everything run better and make PMs easier. Okay. some people in the old days would buy both, all right, because they like to have the weed whacker and the lawnmower. So that machine all the way to the right will do both, okay? So you plug one hose in and hook it up to the quick connect, and you can run it up and down the press rows and clean molds. And then you can set up another set of hoses and hook it up to a big airline and do a semi-annual cleaning, just housekeeping like we talked about. So that is the lawnmower and the weed whacker. Just a couple of case studies. This company, MPC in Walworth, Wisconsin, they make auto parts for GM, Chrysler, Harley Davidson, Nissan. After studying it, after having it in place, they had a 40% reduction in mold maintenance. They had a 50% reduction in mold maintenance costs. Okay, just on injection, and they had 40 machines. Reduction in downtime, significant reduction in scrap, increased employee safety. I know dry ice seems like it's unsafe. It's really not, but what is more unsafe are solvents and reaching around and stuff and getting your hands on the tool. And they paid for this thing in 3 months flat. Okay. Another one, A. Raymond. This is a French company. They're making aerospace parts and solar panels and things like that. They had a 25% increase in uptime. They took their clean time per tool from 4 hours to 45 minutes. Could you imagine if you had an extra 3 hours and 15 minutes per tool to keep moving or make parts? It passed all their validation tests. The operators loved it. They loved the fact that they were using a recycled byproduct, and they paid for their machine in 4 months. This is what you need to set this thing up. You need a compressed air system. Of course, most plants have compressed air. High flow, if you want to do housekeeping, 130 CFM at around 80 PSI. Low flow is going to be a quick connect, 3/8 half-inch line, 50 CFM at whatever pressure you dial in. Really, honestly, to do off-gassing and things like that, you can run it really low pressure, which brings the noise down. And then, of course, you need a box of dry ice that you get delivered from your ice supplier. So you need air, you need electricity. It's going to plug in the wall. It draws about 5 amp. And dry ice. PPE. Well, the PPE that we use, you're already probably wearing anyway. Eye protection, ear protection, and gloves. Oftentimes people think, oh my gosh, dry ice, if you hold it, your arm's going to fall off. We're going to need some of those big welding gloves that go up to your shoulders. You don't really need all that. Just a regular pair of cotton work gloves is all you need. Now, we put in our manual that you should wear everything known to man that's safety related because we have to watch it too. But really, that's all you need. That's all I ever wear. I don't even wear gloves because all that gloves do is keep your hands clean. Okay, this is fast, okay? You're cleaning things in place while they're hot with zero chemicals, zero solvents. You're not abrading anything. You're not interfering with electricity. If you happen to go over a control panel or something, it's not a problem. In fact, most people are cleaning motors and control panels while they're live. And there's absolutely no secondary waste stream. That's what makes it fast and good. What else have we learned? Well, we do have 100 applications in 52 industries. About 45% of them is some kind of a mold cleaning in plastics, in rubber, in poly, in foundries, so casting and molding metal. Dry ice is not dangerous. Dry ice is easy to get. Learning to use this thing takes about 10 minutes. And if you forget how to use it, or if you have a new employee, we have a QR code on the machine. The operator can take a snapshot of it. He can read the manual from cover to cover if he wants, but really he can watch the entire training video on that particular model and do retraining. Also, our service people will come around to your place on a scheduled visit and do a free preventative maintenance inspection. He'll put a safety sticker on the machine and retrain new personnel, no charge. If it happens to need something, he's usually got it on the truck. Okay. CO2 emissions won't close your facility. Dry ice is a byproduct, so it's friendly for everybody. And the PPE is stuff that we're already using. I am ready for questions if you're ready to give them to me.
Mike, thanks for that. Great presentation.
Thank
If
you.
you guys have some questions, go ahead and send them into the Q&A tab at the top of your screen right now. We've got a couple that have come in already, so I'll get started. Um, first question here. How much does it cost to clean a mold on average?
Well, of course, that would depend on the mold and the geometry of the mold and the difficulty of the mold. But, okay, so you calculate the time, the trigger time versus the pounds per minute. Okay, so if you were cleaning a mold that's making a dog bowl, okay, just for example, I would say you could clean that mold in about 30 seconds. On a low flow setting, you're at about a half a pound a minute. Okay. And we are average 40 cents a pound. So you're talking about 20 cents. Okay. Now, if you're doing a dashboard or something, of course, it's dramatically different. But these are things that you can discover on a trial program. We have these programs where, we can do a demo for you, but you're not going to learn what you need to learn in a demo. So we have these programs where you rent one and you try it on for 30 days and do that kind of math. But it's different for each one, but it's really inexpensive compared to the way it's done now.
Thank you. Here comes another good one. Does dry ice leave a texture on the surface of metals like sand or shot blasting?
No, absolutely not. As proven by the Kettering University study that we exposed. No, we will not. We cannot. Hey, there are people out there that wanted us to do that. A lot of tool and die makers, they want us to profile it. It's just not our animal.
Great. Here comes the good one. Can this be used in clean room applications?
It sure can. A lot of people are using this in clean rooms. You just have to watch the CO2. Okay. So, and I'll explain that real quick. CO2 is when you force its sublimation, it turns into a gas. It's heavy. So it goes down to the floor, out to the wall, and up to your nose. So if you're in a small confined space, you have to move that air. So you tend to evacuate it low and bring fresh air in high. But clean rooms have makeup air anyway. So you just set your makeup air a little higher than it would normally be. But yeah, clean rooms are good.
Perfect. Let me get to another one here. Is it safe to use on a mirror finish mold?
Yes. Again, I could take the M off an M&M.
Yeah. Oh, here comes another one. Let me.
Hey, as a matter of fact, John, back, this dates me a little bit, but back when DVDs were new, we were the guys that were molding the cases, just those clear plastic cases, those were mirror finish molds, and they were scared to death to let us in there. But Sony up there in where they went from the record business to the DVD business, they had several of these cleaning those mirror finish plastic molds. Mm-hmm.
Good. This one's a real good one. I'd like to use this to clean extrusion dies for fishing line. The problem area tends to be small holes. 0.032-inch diameter is typically the smallest. Would that be possible?
So he's what, extruding fishing line through an ID?
Yeah.
Okay. I don't know. Actually, I think we could clean that out. Going back to the tire business, when you put a green tire into a mold and you expand it out, you see a tire's got a little nip on it all around it. That's from the venting. Okay. When you put the dry ice on there and with the air pressure, it cleans that whole vent out. The tire mold's this thick, and you can see the gas coming out the back. I'm saying, I'm pretty sure, but that would require some testing.
Okay. Thank you.
Which
Here's
test do you
go-
accept the testing at your site?
Yes, we'll do testing at your site, or you can send it to our factory here. We have the state-of-the-art test facility. You can go online with us and watch us do it and stuff like that. Either one.
Thank you.
Gotcha. Here's a safety question. Our safety folks are worried about oxygen levels for the operators in a confined area in the machine. How much CO2 is used?
Okay. For mold cleaning, that machine is set at 0.5 pound per minute. Okay. Now, CO2 expands when you force its sublimation to about 700 times its size. So in confined space, yes, you have to be concerned about that, and you have to evacuate and make up air. All right. Now, confined space is different than factory floor. If you're out on the factory floor, you're going to have a long day trying to fill that whole plant up with CO2. But we have matrices that you can measure the room, and we'll show you exactly how much makeup air you need. We do it in our test cell. It's done all over the world. You just have to know the right formula.
Thank you. Thank you. Here's another good one. Can this clean off gas residue of the core pin in a micro injection mold tool with core pins that are 0.02 inches?
Yes.
Okay.
No
Easy
problem.
enough.
Yep. You bet.
You talked about setting the recipe for different gloss levels.
Mm-hmm.
Doesn't that mean it can alter the texture?
No.
Okay.
Let me give an example. Toyota Georgetown, they're molding their own dashboards. They were sending them out to have them vapor honed to get the right gloss level, but they found that when we clean them with microparticles and clean them online, it didn't affect the gloss level. So it wasn't the adjustment of the gloss level came from the abrasion. If you can clean it back to its original design point, the gloss level actually improves.
Gotcha. Thank you. Here's a good one on storage. So, what is the normal loss of dry ice per day when stored?
4%.
Percent.
Yeah, you're going to lose 4% a day. Over a week's time, 25%. Okay. Now, if the operators, if you're going to have cleaning day, you're probably going to go through a box in a day. All right. So, now if you're cleaning molds, you're probably not going to use as much. And after 7 days, you will still have dry ice in the box. But what happens is dry ice is a desiccant. So it draws in moisture and it starts to deteriorate the molecular structure of the pellet. So it doesn't feed through the machine very well, nor does it clean very well. But its effective use is 7 days. But you are going to lose 4% a day to natural sublimation.
Gotcha. Here's a good one. What is the ballpark cost for the low flow unit, and what is the anticipated life of that unit?
So we have two versions of it. We have the smart version of it and the one that doesn't have the IoT and all that. They're around $30,000 and up for
Okay.
a machine, a cart, the gun, hose, nozzle, setup, training, all that stuff.
And the life of that unit?
Oh, well, gosh, we've got those machines are still out there in the field working. We build good machines here. We're not the only ones doing this. You can go to Amazon and buy a $2,800 cleaning machine. It's a toy. It is not designed for you and your plant to use for the next 10, 12, 15 years. Honest to God, those micro clean, low flow units that we've sold 15 years ago are a lot of them are still out there running, a good deal of them. And there's
Very
really
good.
no scheduled wear parts. Does a switch go bad? Sure. But they are very, very reliable.
Thank you. Here comes another good one. Can this be used to clean burned plastic on an IMM screw?
No. Okay, let me qualify that a little bit. The screw, depending on the material and depending on if the screw is chrome plated or not. If it's chrome plated, it probably will pop off. All right. If it's not, it might be cleated on. So it's hit or miss. Now, if you will clean that screw as you're pulling it out of the barrel, yes, it will clean it off. It's kind of a trick to do, but people do it all the time. But those big built up burnt mounds of plastic on top of the extruder and everything, no. But if the screw is just tarnished and has burnt on residue, if you can clean it while it's hot, yes. It's like a tire. And I hate to go back to the tire mold. It's just the experiences are so dramatic. A cold tire mold takes me about an hour and a half to clean just to do the sidewall. Okay. If I clean it at temperature, 11 minutes. So, and then the reason for that is the thermal shock is doing more work. You get more of a thermal shock than dynamic. It's the same thing with a hot screw.
Gotcha.
Make sense?
Thanks for that. Yeah, thanks for that explanation. Will this help in any way cleaning internal vents in a tooling stack up with internal vents and dump reliefs with thermal aspect of dry ice?
I don't
Usually
think
have
so.
to pull. Okay.
You have to be able to see it. We can't go around corners and through stuff.
Gotcha.
Yeah,
That makes sense.
and if the plastic has set up, it's set up. I'm not gonna be able to break through that.
Let's get one more. Are there any solvents, residues, etc., that it cleans poorly?
Well, not in your world. No. I mean, there's things out there that are pretty tough in the world, but in the plastics world, no. Or rubber, we haven't found anything that it just doesn't work well on. The off gassing and all that stuff works well.
By the way, people who put it the comments, please use Q&A. People put in the chat doesn't have a record that I can share with the presenter later. So please use Q&A instead of chat.
Gotcha. Yeah, thanks, Goy. I'll read a couple more of these,
Sure.
even from the chat. But yeah, please keep putting the questions in the Q&A tab. Are there different nozzle lengths, orifices, etc., for different types of jobs?
Yes, we literally have 100 nozzles. Well, we have 100 applications in 5200 series, so we have to. But most injection mold guys have a straight one and an angled one. That's all you need. Now,
Gotcha.
if you have a particularly weird thing that's deep and up in here, we can modularize extensions and different things to address what you're trying to do. And we have field technicians that have all the nozzles. And if you want, they'll come out and spend an afternoon with your operators testing various things to find the right combination of modular cold jettiness that you need to make it work.
Thank you. Another good one. If cleaning carburized material, it seems like it would be recommendable to clean the part hot. Is that correct?
Hotter, better.
Hot is better.
The hotter, the
Gotcha.
better.
Okay. Back to the chat. Another good one here. What kind of pressure comes out of the nozzle?
Well, there's a range. If you're using your plant air, you probably have it regulated to 80 psi. Okay. In the low flow, you're going to be, and remember, in our world, volume of air is more important than pressure of air. Okay. Pardon me. So in our world, if you're cleaning a tool, you've got 50 CFM at 80 psi, you could also probably clean that at 30 psi because the off-gassing is not that hard to clean. It's the geometry and intricacy of the mold that makes it hard to clean. It's not the contaminant. So when you turn it down, you're going to lose a little speed. It may take a little longer, but there is some noise to this thing. So yeah, you would gain some safety stuff. But if you really wanted to get after and clean it fast, you would just turn the pressure up. Either way is not going to damage the tool.
Okay. Will this remove the RF85 coating from the molds?
The RF Q85, that's what, like a silicone protectant or release
I
type
believe
thing.
so. Yeah.
Yeah. Not if you adjust it. If you adjust it down.
The pressure down.
Yeah, you adjust the pressure, the particle size, and the feed rate. Again,
Okay.
I can take the M off an M&M.
Gotcha. Yeah.
Yeah.
What kind of scheduled maintenance is involved?
Well, on the cold jet models, there really is no scheduled maintenance. Those tabletop units, we found that after using them 10 years, you might need the new blades because there's a shaving that goes on. That's less than $1,000. There's no wear part or scheduled maintenance. Now on the entry level machine, the Ice Rocket, that does have a wear part that every 500 hours gets a part, and it's about $600. And that is a we bought that company. And so we still use it because it's a good little machine. It does require a little maintenance, but the cold jet machine made in Loveland, zero scheduled maintenance.
Gotcha. Thank you. A couple more here.
Sure.
How much operator training is needed?
An operator can learn to use this thing in about 10 minutes. Okay. There are 5 do's and don'ts. And the do's and don'ts just keep you from breaking the machine. For example, for some reason, people want to run the machine and leave the hopper open. Okay. You leave the hopper open, everything you're cleaning ends up in the hopper. Then it boogers up the feeder mechanism, and that can be expensive. If you leave the lid shut, it'll last forever. Okay. But there's some nuances to dry ice that those 5 do's and don'ts in the training will just make your day go well. So you can learn to use it in 10 minutes. When I do an install and training, I'm not there 30 minutes. And a lot of that is hook up and leaving. Like I said, there's a QR code on the machine, and an operator can train himself by watching a training video.
Good. Thank you. Here, last one. What if someone accidentally shoots someone else with the gun?
They say, ouch. In my career, I think I've been shot about 200 times. It's unpleasant. It stings. It won't tear your skin open or anything. You're not going to lose a limb. The closest thing I can It's like kind of like taking a hard crack with a belt across the back of your arm. It stings, but it's not a trip to the hospital either.
Okay. Gotcha. Well, thank you. I appreciate the all the information. Again, I thank everyone for joining. This was a great webinar. Thanks, Mike, for
Yeah, sure. I was
presenting on
pleased
it.
to do it.
Yeah, absolutely. And then I just wanted to mention again, we do have 2 more of these scheduled coming up in August and September. We have SigmaSoft virtual molding and Cyansco material manufacturer. So stay tuned. Look out for the email invites for those, as well as social media posts about those webinars coming up. But unless
Yeah,
Glenn,
Mike,
if you got anything to.
Mike, thanks as always. Appreciate
My
your
pleasure.
partnership over the years,
Yes.
and I learned a lot myself actually
Well,
from
we
this.
are
That's fantastic.
we're all about education here, and my phone number's on there. My new job here, we decided 30 years was enough on the road. My new job here really is to take phone calls from people that have deep questions, and you can also email me anytime. So I'm happy to help.
Thanks everybody for joining. Appreciate
Yep,
it.
great.
Thank you.
Thank you very much.
Thanks so much.
Bye.